there a question about this one? All right, no questions. Let me erase this and bring us back into focus. All right. Number 2, solving a perimeter problem. It says a campus group is setting up a rectangular angle area for a tailgate bash. They have 100 feet between 2 roads with 440 feet of fence to use. What length will they use up the full amount of fence and enclose for the biggest space? We're going to have 220 feet left over. As shown here, you have 100 feet on this side, 100 feet on this side. So since it's a rectangle, the top and the bottom must be equal. So that leaves you 240 feet. If they're equal, you've got to divide it by 2, making it 120. The diagram of 120 on the top, 100 on each side, and of course 120 on the bottom. And the diagram helps you solve it. And that's all they're saying here, is that sometimes in math you have to draw out a picture, maybe to help you understand it. The trial and error problem, in which your duties as a new hire is you're supposed to find and purchase 12 door prizes for a staff meeting. And they give you $110 to spend. The boss wants some insulated drink cups, a smartphone stand, and the mugs cost $11 and the stands are $8. How much of each should you buy? Again, you got to buy a total of 12. But this is the diagram way to do it. 1 cup, 11 stands is $99. Why? Because we know the cups, so they cost $8 a piece, or the stands cost $8 a piece. The cup costs what? How's it? 11. So does that fall in the budget? Well, you have a little bit left over, so you can do a little bit more. So you just start building your diagram. 1 cup, 11 stands. 2 cups, 10 stands. Now notice that when you add up the 111, it always has to be 12 because you're getting only 12 gifts. So you still have money to spare. So you go 3, 9, still money to spare. 4, 8, 5, 7. 5, 7's pretty close. What would 6, 8 do? Well, you know that. It's 6 times 11. Times 8. It would exceed it by too much. So how many is 5 and 7? This is always a good one. People ask me sometimes, what would you rather be paid? An hourly wage or a salary? Well, it says here, if you work 40 hours a week, and they give you $19.20 per hour, multiply it times 52 weeks, we want to know if that is going to be better than the 41,000. Well, it's a math problem. So you simply got to take 19.20, multiply that by 40, multiply that by 52. And that's what the calculator for. So we'll try it out. By the way, some of these problems are still easy, but they do get painful in the future. And I don't want you to, because there's some good ones and some bad ones, and this is still pretty much pure math. With 19.2 You can add the zero, doesn't have any effect. And since that's what you get paid per hour, and you get paid 40 hours a week, we'll multiply that times 40. That's going to give us a number. I could do that, and then I could multiply it by 52 and get the ultimate answer. I'll show you what that's 52. $39.36. As I said, you could do 19.20 times the 8 or 40. Get a number, and then multiply that times that picture answer, 52, which is the same thing, and you get the same answer, 39,936. So your calculator has a different way, or can do the bottom line that you can see here. That if it took 40-something thousand a year as your salary, that it would appear now, as we all know, that salary, in fact, you'd make $1,000-something more, pays more, but extra hours. So a lot of people opt out for the hourly wage. Now, solving the problem using calculations. This is a calorie problem. This person needs to buy 100 calories, 7 days. They don't want to shed body fat, and so on. We calculate how many calories we need to burn each day, then divide by 100. See how many miles that need to be walked. Well, in order to burn again 100 calories, you got to walk a mile. If you take this number 3500 divided by 100, you're walking what? 35 miles, 5 miles per day, 7 days a week. How do you do the math? Again, 100 calories per mile. So you divide 3,500 by 100. That's how I would do it. That gives you this number. And if you divide that by 7, because 7 days to do it, you got to do 500 calories per day. And that's just to lose a little bit of fat. Now, on the other hand, another way to do it is to do a little bit of walking and eat a little bit less, and don't eat sugar. Really quickly do that. Synthetic sugars. It's better to use that natural sugar, that green one. Because they know what I'm talking about. Dark sweetener. The natural sweetener. Stevia is correct. They say that's supposed to be the better one for you. My sons say so. I guess they're right. Recognize a problem with no solution. I'd love to give you my own. I'm just going to do a simplified version. Problems built. So let's start out with 7 equals 6. We know that's not possible. So if we had x plus 7 equals 6 plus x, We know there can't be a solution. We divide this by 2, we divide this by 2. It's not possible. I mean, we can make it look like something like this, but right away you should be able to see. And then you can multiply this by pi, multiply this by pi. Make it as complicated as you want. But when you cancel this, cancel this, cancel this, cancel this, you cancel the x's, cancel, and whatever you left, you can do this is not possible. No solution. And by the way, in math, there's problems like that all the time. Hope that makes a little bit of sense. Most people have common sense and know there's not a solution all the time, always. I mean, it's just sometimes there's no solution. So that's 1-3. Any questions about 1-3? Let's go to 2-1 then. Set theory. Now this is a whole different ballgame. Let's just talk about populations in the United States. As you can see, they're shifting. In 1960, the populations were such. Hispanic, and so on. Notice that the population in 1960 for white people was about 80%. It dropped down to 60, and it's going down less and less. Hispanic population is going up and up and up. Asian population is going up, and the black population is fairly constant. This is just interpreting and reading a graph. Now, is it accurate? I don't know. Probably pretty accurate, but things can change, as they well do. Let's go right into it. A set is a collection of objects. It should be defined so it's specific. An element is a member of the set. So you have members 2, 5, and 7, 5, 2, and 7. The order doesn't really matter here. Example 1. The months that begin with M. In the English language, they are March and May. Solution is separated by a comma. The roster method. Write the set of natural numbers. And natural numbers do not include negative numbers. So it's 1, 2, 3, 4, 5 because it's less than 6. Now, write the set of odd natural numbers greater than 4. It's 5, 7, 9, 11, and dot, 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 keeps going on and on. This has what we call separate notation. And it's looks like this. Little mark there. This is pretty easy. This is the listing. They call it the roster method. Now, understanding set notation. This is 27, and it says decide whether each statement is true or false. States west of the Mississippi. Oregon is west of the Mississippi, so yeah, it's a member of A. 27 is an element of this, so we have to figure it out. 1, 5, it's every 4 numbers. After 25 comes 4, it's 29. 27 is not in this, would be is no. This one says Z is not an element of this, and of course it's there, so this is also false. So 3 is kind of tricky, but I hope that makes sense. You guys good with number 3?